So with that, I'd like to introduce Steve Boisvert, Knowledge Aware Consultant at Auros Knowledge Systems, to take it away.
All right, thank you, Amy. Hello, everyone. Thank you for taking the time out of your day to come learn more about connectors and automated rule processing. As you know, if you've been to a previous conference, you know that I'm passionate about these connectors. One of the things is we know that Auros is not the place where you design and test your products, but those are the places where knowledge needs to exist. And so for today, my focus is to basically just explain to you how connectors and automated rule processing can be utilized to advance a process's ability to become knowledge aware. And my plan is to walk us through some baseline information. So to kind of set the stage, I sat through a few of these other presentations, and we've touched on some of the basics of some of the fundamental technologies that Auros relies on. And for those that aren't completely immersed in Auros, I want to take the time to establish that foundation for you so you know what we're talking about. And then what we're going to do is we're going to hop into a live demonstration and show you how these things really work. Some key takeaways that I hope you get from today's discussion. I want you to know, walk away from this with knowing how, Jeff mentioned how Auros is a knowledge operating system. And I want you to understand what it means for Auros to provide knowledge as a service to another application. Also how Auros can provision knowledge into those other applications, whatever they may be. What it means to automate or have automated rule processing. And then lastly, whenever we have two applications connect to each other, how do we keep data synchronized between those two applications? And we're going to take a little look at that here in just a minute. So let's get into it. So let's start off by talking about the transformation of knowledge aware. And Jeff touched on this. He touched on how the knowledge aware technique is much like navigation, and how the navigation app provisions map tiles to you, the individual just in time when they need it, right? So individual map tiles. What I want to cover is how this relates to connectors. And there is a relationship, because in order for that navigation app to work, it relies on a signal, a GPS signal, to understand where you are, to provide that context so that navigation app can provision the right information to you. And so when we're talking about these connectors, using connectors to applications that you use to create and design your products will allow us to sense that context, to get those signals. That way we can provision information just in time at the point of need. So to understand how this all happens and really what's involved in these connectors, there's three technologies I want to touch on. And like I said, for those of you that are very familiar with Auros, this is just going to be a recap, but those of you that are not, there's some key information you're going to need to walk away with. So the three technologies are the knowledge packet, the assessment control, and the rule processing engine. And we're going to take a look at each one of these individually real quick. So let's start out with the knowledge packet. So we've touched on this in a couple other presentations, but you haven't really seen one. And the knowledge packet is just a structured unit of know-how, right? And there's three inherent properties, qualities about a knowledge packet that you need to be aware of. They're granular, they're actionable, and they're modular, right? They're granular in the fact that they're not meant to be a novel, right? We want them to be, they're best aligned when it's to a discrete concept. They're actionable in the fact that they can perform work. They can do calculations. They can be part of decisions. They can self-evaluate in some cases. And in terms of today's presentation, when I get into the connectors, and specifically the CAD connector I'm going to get into, there's a specific part of the knowledge packet you need to be aware of, and this thing we call a value table. So this value table is like a little mini knowledge model in itself that can be embedded within a knowledge packet. And this value table allows the author to be very precise with the concept they're trying to transfer to the end user, what it means to be compliant to whatever their knowledge is here. And other thing about a value table is that once they're constructed, they can be used and processed by another application. And we're going to see that today with CAD. And when we look at this value table, we can see that the author's trying to convey that there's some minimum pin locator pin engagement that is related to 45% of a part thickness. So part underscore thick here on the middle of the screen is a parameter that we need to be aware of. And where better to get that value for that parameter than within a CAD model. So we can provide it with a value. And once we have that value, then we can determine if the pin engagement meets the criteria outlined by the author. So we're going to look at how these interact here shortly. But the second technology we need to be aware of is the assessment control. And the assessment control is a comprehensive toolkit used to provision, evaluate, and track collections of knowledge. So here's an example of a basic assessment control. And this assessment control is collecting relevant knowledge for a certain context and for a particular project. And what you're looking at in this example is each of these lines that you see on this assessment control is an individual knowledge packet. And how that knowledge was utilized on that project is being evaluated. And you can see that with some green and yellow statuses. And we're tracking that information so we can improve knowledge over time. Another aspect of an assessment control I need to be aware of is if we take out all of the text and kind of this information that you see on this screen, and we boil it down to just those parameters within those value tables, we have this thing called a parameter view. And it allows us to look at just the parameters and see their influence on how that knowledge is being evaluated for a particular project. And we're going to look at this here shortly when we get into the demo. So just be aware there's a couple different views within an assessment control, and we're going to take a look at both of them. The last technology I want to talk about is the rule processing engine. Now, the rule processing engine is a collection of services that help evaluate knowledge packet information. But then the rule processing engine can also provide data in the form of like a status or calculated values or even end user messages back within the flow of work. And to better describe that, I have a little model I want to show you where we have Auros on the right-hand side, and we have a source application or whatever the context is coming from on the left. And those could be anything. So, for example, a CAD system, a modeling tool or simulation tool, PLM system. Really, there's just unlimited potential for source applications on this left-hand side. So what happens and what's the communication between the source application and Auros? And the first thing that happens is from that source application, the one thing we want to know is context, right? It's that GPS signal. What are you working on? What milestone are you in? What materials are you using? What kind of attributes can we get from that system to pass to Auros to then understand which collections of knowledge are relevant for you, for your needs for what you're doing in this source application. So first thing we do is send context. Once we know context, we're then able to harvest the relevant knowledge packets, take those knowledge packets, and then pass key parameters back to the source application, right? So those key parameters like we just saw in that example, like part thickness and pin locator engagement. Once we have those parameters pushed into an application, what we're looking to do then is bind those parameters to information within that application. So things like attribute data or dimensions or measurements. If we combine those parameters to an object, we can send the values back to the rule processing engine where it can determine whether or not you're compliant or not compliant to the rule or series of rules, and then send into the source application a response, letting the end user know visually, are you compliant, not compliant, or other to a particular rule, along with any kind of end user messaging that goes along with it to help that user understand why or why they're not meeting a requirement. So with all that, you have that response going back into the application. But then in the background, because we're tracking all of that, we're able to generate a wealth of reports within Auros outside of the source application, which is very beneficial in a lot of cases, especially where licensing could be an issue of having people be able to get into these source applications to extract that data. So that could all be available offline inside of Auros. So those are the basics. So now what I want to do is I want to shift gears and I want to do a little demonstration. Now, this isn't the most innovative demonstration I've ever done, but this demonstration is going to allow us to better understand how the communication and knowledge transfer, knowledge servicing all works. And for that, I'm going to use NX. And there's a few reasons why I'm going to use NX. The first reason is it's because what I have available here, and I'm not brave enough to do a live demo remotely on a desktop back in the office. Two, the version of the NX connector I'm going to go through doesn't have a lot of automation to it. It's very kind of basic in nature to allow me to go step by step to help explain to you what is going on. And three, I know there's a couple other presentations that are going to occur that are going to highlight some other connectors. Dan Cronin's going to talk about the ship constructor connector tomorrow, so you'll see that, how that is used. And then Jim Carter from MIT Lincoln Labs will also show you the SolidWorks connector and how that functions during the cool KPAC contest. So with all that, let's change gears. I'm going to put my CAD designer hat on, and we're going to hop into the demonstration. So let's get out of PowerPoint, and I'm going to open up NX. So hopefully you see my NX screen here, and what you're looking at is a block. So for our shipbuilding friends on the call, they know what a block is. For non-shipbuilding friends here, a block is just basically a structure that gets built offline, and when they're ready to put it on the ship, they lift it with a crane and drop it on the ship. So this block is fairly basic, and it has basically 2 levels with some structure and a series of steps. But as a designer, I know that there's a tremendous amount of requirements around the structure, all aspects of the structure. And it's the same regardless what industry. As we do design, there's a tremendous amount of information we need to be aware of. And for this demonstration, as a CAD designer, I would have to go out and find the requirements for this structure. And actually I have a sample here. Here's a requirements document that contains information all about how that structure for those stairs needs to exist in order to be compliant to this, these standards. So what I would have to do is go through, it's 156 pages. I would have to, go through this document and find all of the ones that apply to me. And it just so happens, I already know that it's around 103. So on page 103 of 156, I would have to find this page of information. And really what it boils down to is, if I know what angle of ascent I want the user to go from the lower level to the upper level, I know what type of application I needed to use, whether it's a ramp or stairs or a ladder. And also from information other than this table, there's these tables that have some other information, like how deep the treads need to be, what's the height between treads. So again, just some tremendous amount of information that kind of gets buried that users have to go and find. So let's start this demonstration off with going to Auros. So I'm going to go into Auros, and I am logged in as CAD user. So I'm the CAD user. And we're going to start this demo from the point that I have been provisioned knowledge already. And what I'm going to do is I'm going to go to My Assessments. And when I look at My Assessments, I can see within My Assessments the different projects I'm working on. And one of the projects for Project A is the demo that we're doing. It is an assessment that has not been evaluated yet. So let's take a look at this. So within this assessment, I have knowledge packets created from basically that requirements document in the form a little different than what we just saw, right? Here's that same figure, but now this figure has been transformed into a logic model down here in the value table. And real quickly, to show you how this works, I have a condition here with a different equipment type and the angles of ascent that I'm going to measure, and then I'll be able to tell whether I'm compliant or not compliant to the rule. And the way that works is by using the rule engine. So if I know the type of application, and incline ladder is what I want to use, and I know the angle of ascent, let's just say it's 45 for this example, which is a value I'm going to get out of CAD. If that's the case, I'm going to get a red condition. It's going to give me this, safety warning. Hey, there's a hazard here. But if this is a different value, then the rules engine processes it slightly different, and I get the preferred. Hey, you're good to go. I could use my incline ladder. So let's see how we can provision the knowledge into the application, and we can see how we can automate that rule processing from the CAD environment. So back inside of NX, I have my block again, and I have my Auros connector button. So I'm going to click that, and that's going to establish the connection to Auros. Now we already know what assessment we're going to use, right? I just looked at it. It was assessment 443. And when I enter that in, I want to see the parameters. Because if you remember our discussion, the parameters are what are getting passed to the CAD application. So when I look at my Auros connector, it's telling me from that collection of knowledge, the CAD application's already matched some of the parameters, riser height and elevation equipment, and it has a value. But there's also a series of unmatched parameters, meaning they're not in the model, that I need to add to the model in order to rule process against them. So my first step is to create the unmatched parameters. So by selecting this, what it's doing is taking those values from Auros and it's embedding them into the NX model. And I'm going to show you how that happened. So if we look at the part navigator over here, I have a reference now within the part to the knowledge packets where those parameters exist. Metal outfitting 2, metal outfitting 12, and metal outfitting 13. So let's take a quick second here to look at something. There's a few different icons, or a couple different icons I see here. One's this little broken link icon, but the second one is there's a green indicator. So I just want to point something out. Because this knowledge packet had a parameter called riser underscore height that was already in the model. The model was already aware of a parameter, which is something that we regularly do when we model. We add parameters in. When that model exists, or that parameter exists in the model, and we make a connection, the rule will self-evaluate and it'll provide that value back here. But if you notice, two of these other ones don't have the evaluation. So let's take a look at this, the first one, the metal outfitting 2. So one of the things is, from within the CAD environment, I can go and see the knowledge that's required. In this case, it's that same knowledge packet we looked at with the inclined ladder. And what I want to do, now that I know what it is, I want to attach, remember we got to bind these parameters to objects in the model. And so for that, I'm going to go to my parameters within the model, and I'm going to go to my angle of ascent. And what I'm going to do is I'm going to attach it, in this case, to a measurement, because that's all I have. And what I need to do in this instance is bind that to an angle. So what I want to do is we're going to come down here, we're going to say this is the angle of ascent. I'm going to choose my object as this line and this line. We get a measurement of 50. I hit OK. That gives me a parameter for a measurement that is going to exist. And I say OK. And what's going to happen is now that value is bound to that parameter, and it's going to go back to Auros, get checked, and we're going to see inside the model a visual indicator of that assessment. So one more, let's just do one more real quick before we take on some questions. We have one more evaluation, the tread width. So again, it's not bound to anything. I'm going to come in here, we're going to go to tread width. In this case, we're going to do a measure, just a simple basic measure in this one. And I'm going to go from surface to surface. So we're going to go from this outer surface on this one, this face, to another face, just so I can show you what will happen. So again, we have a parameter with a measurement of 43 inches. That 43 inches, that value is going to go to the Auros rules processor, and it's going to come back and say, nope, I'm red. But it's not just going to say that I'm red. It's going to provide some information, right? I get an end user message that tells me the width should be something. So as a designer, this is very valuable. I know what I need to do to correct it. And in this quick example, let's just change something. Let's move this. And I'm just going to do a dynamic move. And we know we need to move it about 20 inches to make it correct. So if I do move it 20 inches dynamically, what happens is that measurement changes and the new value gets sent back to Auros for processing. And then that updated value is shown inside of the connector. In the same way, if I just quickly do an undo, move it back, that value changes and I'm back to red.
All right. That's awesome, Steve. We've got 3.5 minutes. I'm actually not seeing questions in the chat. Can you see your chat right now?
No, all I see is the model.
Yeah, because it's taking up the full screen. Well, one question I was wondering, what do you do when a rule is required multiple times on the same part?
That is actually probably the most commonly asked question. And that's a very good question. So what happens is, so what if I had to measure 2 different staircases and I had tread width more than once? What we end up doing is we create instances of the parameter. So we could have a parameter that's related to this staircase, and if we had another staircase, I could create that same parameter with an instance and label it for staircase 2 or whatnot. And then what will happen is the Auros rules processing engine can keep track of each of those instances independently, and I'll be able to see how my width value is either compliant or not compliant to the same rule, but at different locations.
Okay, good. And then do you always have to manually link a measurement to a parameter?
No, you do not always have to manually link a measurement to a parameter. Actually, in this case, the riser height was an example where that value already existed. So it either existed within a dimension or the designer added that parameter into the model to control something. And just by the nature of how we bind parameters together, because their names were the same, exactly the same, we're able to take that value and rule process against it and then send that result back to the model.
Very good. A question, what about CAE connectors? Can you share some more on that?
Yeah, so there was actually a slide that I had in my presentation, but I took it out to give me more time. And it talked about the amount of connectors we have. So the ones that we have off the shelf and the ones that can be created. We don't currently have a customer that that has a need for a CAE connector. So we don't have an off the shelf one available. Although one thing I would like to note is just because we don't have an off the shelf connector available doesn't mean that one doesn't exist. So I would encourage users through the networking time to talk to some of our customers and ask them what sort of connectors they built to their own internal applications. One of them may have their own internal CAE application connector that's already built.
That's a great idea. That's a good reminder to go visit them. One more question. Andre is asking, what CAD tools are linked with Auros connectors? Is Creo one of them?
Creo is one. So quickly to go through the off-the-shelf connectors that we support, we have NX, CATIA, Creo, SolidWorks, AutoCAD, and Ship Constructor. Those are our commercially available connectors for CAD anyway.
Okay. And I just reposted the survey link. It is a matter of copying and pasting the link into your browser. And we really value your feedback. So that's why we're pushing these surveys. So we really take them to heart and apply them to next year's conference. So, and good timing here. We're 5 seconds out from our countdown going to 0. So I quickly want to let you know what our third breakout session is for the advanced track. It will start at 3:20 with Jeff Maffa. And and it will be on AI and learning cycles. And of course, Jeff is the CEO and president of Auros. So let's go ahead and, get your survey links in your browsers. You got about 5 minutes to take a quick break, and we'll meet you back at the next breakout session. Thank you, Steve.
Thanks, Amy. Thanks, everyone.